which probably is very close to my heart. I've been a structural engineer for a long time. I was actually trained structural engineer, did precess concrete as a PhD topic, partial precessing, way back in 1975, PhD in master's in 70, PhD in 75 or something like that, and that was my background. But the moment I joined SERC, Structural Engineering Research Center, as one of the youngest scientists of CSR at that particular time, directly from IIT, just next to us, I was asked by the director that you should take care of what's called polymers in concrete as the subject. That is the topic or the project that I was given, and I was in charge of the whole project area. And we had excellent people from Lehigh University, Professor John Manson, Director of Material Sciences Laboratory, and Professor John Vanderhoff, Director of Surface Coatings Laboratory, who taught us polymers in concrete, and I never studied polymers. That invited me, or that initiated me into something more important, which is basically concrete. I've written a couple of books. I'll quickly go through all those things in a short this thing. The first thing that we should understand is that there is something called structure, which is basically a certain configuration that we put together for a particular application, for a particular use. The structure is built out of a large number of materials. Most of the time, you are either dealing with concrete or with steel. One thing that we should understand is there is something called an interaction between the two. Concrete is a very wonderful material, though people have told me when I was a student in 1965, just now somebody was talking to me, one of our colleagues was talking to me from the university. When I joined, somebody told me, what are you going to do here? I was actually a BSc graduate. And then I joined MSc Pure Physics as a student, by the way. My first joining to the institute was only MSc Pure Physics. But then the head of the department at that particular time, Professor Ramchandra Rao, said that engineering is better for you, so you shift into this thing. So I shifted. Now when I came to this particular side, everybody told me that concrete is a material of the past. There is no future for this particular concrete. But unfortunately, you should remember that today, as a matter of fact, about 20, 30 years back, we used to say that the GDP of a particular country and the development of a particular country is practically denoted by the amount of concrete that it uses. Unfortunately, we don't use concrete, we misuse concrete. As a matter of fact, we really don't make concrete at that particular level where it should be made. For each application, it is different. So one thing is concrete. The second thing is that concrete is a very wonderful material. It's very good in compression, but unfortunately, it's not so good in tension. It's only 1/10 of its strength in tension. So obviously, we have to reinforce it. And for reinforcement, we use basically steel. There are other materials that these days we talk about, including polymer fabrics and things like that. But unfortunately, the interaction between steel and concrete has always got a problem, and corrosion happens to be the largest problem. And probably that was the reason that I was recognized all over the world as a person who has been working on corrosion of steel in concrete. Naturally, you have to know what is concrete, you have to also know what is steel, and then there is an interaction between these two. Now, coming to these two materials, normally there are a very large number of materials that are exploding into the market. Unfortunately, most of these materials are good in their own way, but then have very limited application, and you should know where it should be applied and how much can be applied. There was some question that our earlier speakers were also talking about, that we overemphasize on certain things, we overdo certain things. That also is not so good. So obviously, the basic reasoning or the basic question of testing of these particular materials, how they are effective, how they are not effective, is basically looked at in terms of what is to be tested, or what material is it, why it is, and then how it is, and the authenticity of these things. So why? Why do we need this particular material? There are large number of, for example, I'll give you a very simple example for concrete. There's something called a superplasticizer, very simple material which is extremely useful provided you know how to apply it. And there are some advantages, there are some disadvantages. There is, if you use it a little more, for example, I wrote a book on self-compacting concrete. If you use a little more, then you will get into segregation. If you don't use a little more, then you will have to vibrate it, and that is not self-compacting. So I'll try to go a little fast because I've got a few slides. There is a statistical basis for every experiment that we do. There is, sometimes we always say, I should not be saying these things in public sometimes, but then I'm an open speaker in the sense, I've been a professor, I've been a teacher all my life, even though I was a director and I was also the secretary to the government, cabinet secretary rank and all that. But major question is, where is it that we should stop is a question. For example, for most constructions today in the whole world, not only here, many other places, the minimum strength of concrete is about 30 MPa. That's what is expected in all over the world. Whereas in this particular country, unfortunately, though the IS code specifies 25, we still use 20. That's a basic problem. If you use 20, then your life expectancy of that particular concrete is less than about 20 to 25 years. Unfortunately, that is true. So one should recognize what is required for each particular structure. Do you want your structure to be lasting at least about 50 years? Then you should be talking in terms of 30. Now, there is a question of 30 itself or 20 itself. If, for example, you think that the 20 is very important, there is something called a sigma, a Gaussian distribution of these particular concretes, and the strength of concrete is defined by 1.64 times standard deviation, which is 5, which is defined by the concrete. That means the minimum strength that you should use for that particular concrete, design strength, should be 28. Unfortunately, none of the present day engineers are being told these things. Even the practicing engineers in the field think that if 20 is expected, that is what we give and that is what we get. Unfortunately, that is not true. The minimum that is expected of the Indian Standard Code, even the minimum that is expected of the Indian Standard Code is 28. From the British Code, it's almost about 38. Now, I am not going to go into those Six Sigma definitions and all that. This is what one of our ministers was talking about, that we should go into that Six Sigma region where the standard value that you will get, or the amount of confidence with which you can say this particular concrete is of that particular type is of Six Sigma levels, and there are large number of levels. I will not go into all those details because this is a limited time available. So now what is it that we want to do? We should understand what is it that we are defining, what is it that we are measuring. For example, our dimensional measurements are very, very poor. For example, we say 1 kg, the specific gravity of cement is 3.15. This is what I teach all the students, and every one of the masters and PhD students, or even BTech students, is given that particular value. Measure any cement that is available in the market today, it is never more than 2.6 to 2.8, period. Why is it? Because we have allowed what is called an admixture called pozzolanic materials. And these pozzolanic materials are very good, extremely good. But with that particular type of cement, you can only make about 20 MPa, period. 20, 25 is all that is. You may say that you are getting 30 and all that. That is because you are trying to squeeze out a little more, but they will not work after a certain particular time. Now the next thing that we should, what is the problem that we have? What is it that we are designing these things for? I am trying to give you an overview of what is called rehabilitation and its requirements. I am not talking about rehabilitation itself. That rehabilitation lecture, I know some of my colleagues here, and as a matter of fact, there are other people who are here who come from the industry and then talk to you. So I will not go into that particular thing. I am a consultant to most of them. So obviously, you should know what to do. And the main problem that we are interested in is that this particular structure, all of us, when you drive in this particular street, right about a kilometer behind, you will see that there is something called the AQI in Telangana state, or in this particular region, or in this particular road. The AQI is the air quality index. Unfortunately, we are breathing that. Similar to what is our system, the structures have also got a life, and they also breathe. They also have a certain amount of what is called interaction with the environment. And one of the problems that we have got is carbon dioxide. There are other problems which I will not go into, but this is what happens. We also have to design against what's called cyclones. These are the earthquakes generated from probably volcanic eruptions. There are other earthquakes, there are landslides. I was one of the members of the National Disaster Mitigation Authority, one of the members who wrote a number of documents for the National Disaster Mitigation Authority. And these are problems that we will have to deal with for major structures. You build a 50-floor structure. Today we are talking in terms of 45, 50, 55, 60, 70. Somebody is talking in terms of about 70 to 90 also. But then, what is it that we can service it over a period of time? At the end of 5 years, we always say that service guarantee should be given by the contractor for 5 years. At the end of 5 years, what will you do? How will the resident be able to take care of that? From the government, we always have an attitude that what is called an outcome. We always talk about the outcome. The outcome is that if there is a particular public amenity, the public live in that particular amenity, and the public should be safeguarded from any activity that happens in that particular place. It could be AQI, it could also be a fire, it could be an earthquake, it could be everything. So obviously, one is the government is responsible for it. Somebody might ask, it's my building, I am putting in all the money, it's my land, owned by me, so obviously why do I have to follow any regulations? So the regulations are needed only because the government guarantees you that particular fire safety. When there is a fire or an accident or something, it's the government which comes in, and you ring up the police, you ring up fire division, or you ring up somebody else, and this is all being provided by the government. So obviously, we have a responsibility from the other side to look after your safety and whatever it is required. Now, how do we do that? There are a number of material testing, for example. There are a number of structural parameters. There are a number of material parameters. Some of them are structural, some of them are non-structural. For example, whether it is this cement is white or this white cement is white. At one time, I was asked to actually, when at IIT, I was given a small project by some industry stating that, sir, we have 3 different cements available to us, white cements. Which is the whitest of these things? How do we get that? Everything looks white. Do you think which is the whitest has to be tested? Similarly, there are other questions that we go into, and these ones have to be looked at. Now, concrete, a large number of people think that has been developed over a period of time, has developed over land. Unfortunately, the largest developments are the best concrete developments have happened in the oceans, because the structure that you are talking about, that you are seeing there, is called a condeep structure. It stands at about 120 meters of water, 150 meters of water. Minimum about that particular range. Can go up to almost about 200 plus, but then the designs are a little more difficult. And these condeep platforms require that the towers that are there are to be empty. That means there is a pressure of almost about 100 atmospheres at that particular time. Every 10 meters is 1 atmosphere. So it is 10 atmospheres to 15 atmospheres that we are talking about at about 100 meters depth. So obviously, you have to talk about concrete which is impermeable, which is almost indestructible, and these structures should last almost about 50 years. This is the minimum life period for a steel structure. It is only about 10 to 15 years, maximum 20 years, whereas this structure should last at least 15 to 75 years. So obviously, the structural definition, the concrete definitions have all changed, and the largest definitions or largest improvements have been done by 2 organizations. One is Taylor Woodrow Engineering from Taylor Woodrow Corporation from Britain, and the Norwegian contractors from Norway. These are the two people who pioneered on those particular things. And then today, we stand on their legs, you can say, all those great people, Vennesland, Zar, and people like that, Professor Vennesland, Professor Zar, who are probably the pioneers in this particular thing, using silica fume and other materials. Now, these are the materials that have come into existence, and the design of concrete with this particular material or without these materials have been, unfortunately or fortunately, I have written a book on the modeling and the concrete mixture designs by all the codes. As a matter of fact, I have taken a very specific attitude that we will talk about Indian code at the last, but we start with ACI, we start with, next is BS, and then we also have the DIN code, which is actually the Euro code presently, practically the Euro code. So I've given all the definitions of how these concretes are designed, where these cements are, what is meant by this particular cement. All these things are available to you. The next thing that we need to talk about is steel. There are a very large number of steels, and as a matter of fact, at one point I was designing a structure for a degaussing plant, for the submarine facility of a degaussing plant. We were designing a structure with stainless steel as the reinforcement, because we don't want to use steel which has got magnetic capability. It can get magnetized. Degaussing is basically demagnetizing an entire submarine. This is in the coast of the Vizag docks, which we were designing for some time. Now the next thing that we can talk about is, what are these environmental classes, where these environments are getting into difficulty, what sort of environmental classifications are available in the whole world. How do we test? For each application there is an environment. So you have to understand the environment. Now this is basically chemistry, chemical engineering, you can talk about it. This is XRD. This is what is called the interfacial transition zone. Between the steel and the concrete next to it, there is a small layer of about 100 microns maximum, which is basically the problem with all the concretes. That is the one which deteriorates very fast, and then practically the concrete behavior is defined by what is called this interfacial transition zone. Now the question of admixtures. I told you something about superplasticizers. You can make a concrete of this particular type. You don't see any aggregate there. But let me tell you that there is a 20 mm aggregate sitting inside that particular plate. But you don't see it. So you should be able to manufacture. This is something like making, for the girl students particularly, I'm sorry, girls are much better at this particular rasoi, the cooking part of it, whereas the boys probably have excelled in, some of the boys have done it, but generally what you cook in the laboratory is also something very similar to what you cook at home. So you should be able to generate that particular type of expertise to be able to use these newer materials. The high performance self-compacting concrete, there is another book. These were published by one of the largest publishers in the world, Taylor Francis and Company, CNC Press. These are the people who publish the best medical and engineering publications. I'm writing a couple of more books, but then hopefully they will come out in the next thing. Now the last thing that I would like to say is, what is it that we are trying to build? These are trying to build to last. Now, cement is a very wonderful material, but then it's a pyroprocessed material. It's very expensive because its carbon footprint is the highest. So one should understand what is the carbon footprint and carbon footprint characteristics of these things, and there is a need for sustainable development. I probably should stop here in my opinion, because I have 3 other colleagues who are going to hear, but I'll give a short introduction to something. In sustainable developmental goals, UN has given some 17 different parameters. The 18th one is kept for yourself. So I always like that number 18. There are 17 different parameters, and it says sustainable developmental goals. We resolve between now and 2030. 2030 is just about 5 years away. This was almost about 20 years back, this particular definition was given. To end poverty and hunger everywhere. I don't understand what they are talking about today, even today. To combat inequalities within and among countries. To build peaceful, just and inclusive societies. to protect human rights and to promote gender equality and empowerment of women and girls, etc., etc., etc. Are we anywhere near any one of these goals? I don't think so. So my opinion is that we should try to look for those things at the end of the day. So look at advanced cementitious composites. I am not going to go any further. Look at highly advanced cementitious composites are available for repair and rehabilitation. And one should, I think some of our colleagues will give you some nuggets. I don't think anybody can really give. I talked in the morning. I told you there is a booklet which is published by the Admixtures Manufacturers Association. This is called Concrete Chemicals Admixture Manufacturers Association. There is an admixture, and they publish what is called a directory. And this directory contains almost every material that is available in India, and it is revised from time to time. This is published by, actually it was an idea that we started, and one of my very close friends, MC Baushimi, Samir Surlekar, started this particular thing, and then started this first, and then we published the first small report, and then now it is available as a directory. You can get one of those things and then understand where each one has an application and where each one can be utilized. Repair and rehabilitation is an art and a science. One should be able to go there. The first thing that we do is what's called a visual inspection. Then there is something called an experimental verification, or the investigation with various equipments, like for example it could be a Schmidt hammer, which is basically for strength. It could also be corrosion potentials. It should also be corrosion characteristics of the steel inside. All those characteristics, after having investigated, one gives you a recipe of how this particular thing has to be repaired. Whether it should be repaired for strength, whether it should be repaired for corrosion, whether it should be repaired for deterioration of concrete. These are all different characteristics. One has to understand each one of these things and then come to a conclusion that this is what is the recipe that we are going to follow, and hopefully at the end of the day we come up with a structure which is rehabilitated. Rehabilitation means that it's called Instandsetzung in German. I was a Humboldt Foundation fellow. I lived in Germany for a couple of years. So obviously there what we do is make sure that the structure should be able to at least withstand whatever it was supposed to be catering for. Now, over a period of time, sometimes the structure has to do more than what previously we had only this much loading. Now, the structural loading characteristics, they have to change. Then you have to change the load bearing capacity of each of the columns, beams, etc., etc. And these are all characteristics which we go into. So, with these few words, I am trying to tell you that repair and rehabilitation as a last word. For those who are probably younger in this particular audience, I am not talking about my colleagues here, we are all quite old to start something new at this particular point of time. But then the amount of money that is available in repair and rehabilitation is about 5 lakh crores as of today in Hyderabad. Anybody who wants to do that can do that. But then please don't think that repair and rehabilitation means only whitewashing. Next to that is what is called waterproofing. Please don't think these are the two smallest things that you. Waterproofing is very, very important, extremely important, to the extent that the life of the structure depends on the waterproofing that you do at the time of building it, not later. Please remember this. Any later waterproofing is only a cosmetic. 90% of the time it is cosmetic. Even if you do it extremely well, it is only supportive. The structure should have waterproof capability or waterproofing capability at the time of building, and for that the structural strength and other things have to be properly adjudicated. Thank you, gentlemen, for giving me this opportunity, and I hope that I have conveyed the message.